Part C of this problem asks us to find this same limit using algebra. So let's start here, and we'll say, well, that is equal to the same thing, except for we could try substitution. We could try plugging in -1 for x. So let's see, we'd plug in -1 squared. That would be 1, I guess. And we could plug in a -1 up here, so -1 times 3 is -3. Notice what would happen. The numerator would be 0, and the denominator would be, let's see, 4 minus the square root of, that's 15 plus 1 is 16, so 4 minus 16 is 0. 0 over 0. That's not useful, but we might actually be able to use a different method. So what keeps us from using algebraic cancellation? Well, there's a square root in the denominator. How can we go about getting rid of a square root? Well, we need to multiply by the conjugate. What's the conjugate of 4 minus the square root of this? Well, the conjugate is 4 plus the conjugate of that. Now I can't just multiply by that, I need to multiply by this divided by itself. Oop. Didn't quite work right. I'll put another set of parentheses to hopefully clarify what we're doing here. Notice that I'm allowed to multiply by a clever 1, and this choice of 1 is special because what it's doing is I calculate, I'll type in the limit again. I calculate the top simply by multiplying these two terms. So I have 3x plus 3 times, let's see if I still have it, yes, the conjugate. And on the bottom, I'm able to distribute all of these pieces. So I have this piece times that. First I do 4 times 4, that's 16. Then I'll do 4 times the square root. That'll give me 4 times the square root. Then I do negative the square root times 4. Those terms cancel. That's the beauty of conjugates. And so the last term is negative the square root times positive the square root. That just comes out to negative x squared plus 15. That is much simpler. Now what shall we do at the end? Well, we can move to our next equation and say the limit, what do we have in the numerator? I'd like to get a common factor, so I'll start by thinking about the denominator. Let's see, I have 16 minus x squared and minus 15. So that's just going to leave me with a 1 in the denominator and a minus x squared. Okay? Now I'll take that, and I need to simplify still farther. What else could I simplify? Well, notice that this is the difference of two perfect squares. So we could write that, or rewrite it as 1 minus x, 1 plus x. Okay, that's all the way factored. Do you see anything like that on the top? Well, I notice this term has a 3 in everything, so I could factor out the 3. Now, notice that I have an x plus 1 on the top and a 1 plus x on the bottom. Remember, addition is commutative, so x plus 1 and 1 plus x are exactly the same. I'll take this and I'll cancel those two terms. So what's that look like? Looks like me deleting the term on the top and the term on the bottom. Now what shall I do? Well, since I have used algebraic cancellation, I should go back to substitution and see what will happen. Now, what would happen if I substituted in a -1 for x up there, and a -1 for x there. Well, that would give me, I'll take out my limit because I've just applied that limit. That would give me -1 squared is 1 plus 15, that's 16. And on the bottom, 1 minus -1, that whole thing appears to be 2. So it looks like I have 3 times 8 on the top divided by 2. That equals 12, and it's the same answer as the other two methods of calculating the limit.